And this is the TWIS Minion Science Island Hangout. I'm Ed Dyer in Connecticut, and joining me are Dale from Canada. How you doing, Dale?
I am awesome, 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 awesome.
That's a lot of awesomes.
That's great. And we have Pamela. Pamela and guest. We can't see the guest exactly, but that's okay. How you doing, Pamela?
Good. There she is.
Pamela?
Where it's winter where we are.
That's good. Pamela, new mother, soon, well, future lawyer, and presently goat herder. I've seen you milking goats.
Yes.
Hey, that's what my last name means.
Really?
Yes.
Yep.
Really?
Patrick the goat herder.
Yep.
Wow. Do you have a staff?
Wow.
No, but the family crest is a goat.
And that is, of course, Patrick.
Hello.
How you doing?
There.
Okay. We have actually, for this hangout, there were 16 people who indicated they might or would be going. And so I sent out 16 invites. I have no idea if anybody else is going to show up or not. If they do, they're certainly welcome. But I'm going to start with the first story, which I picked out because it applies or something Pamela can relate to. It has to do with newborns, babies in their first year, and possibly developing immunities to allergens. And I have my cheat sheet here so I can discuss the story. And this is from Johns Hopkins Children's Center. It says, infants exposed to rodent and pet dander, roach allergens, and a wide variety of household bacteria in the first year of life appear less likely to suffer from allergies, wheezing, and asthma. Previous research has shown that children who grow up on farms have lower allergy and asthma rates, a phenomenon attributed to their regular exposure to microorganisms present in farm soil. Chelsea's getting plenty of that, I assume.
Yes, she is.
Other studies have found increased asthma rates among inner-city dwellers exposed to high levels of roach and mouse allergens and pollutants. The new study, overall, allergy and asthma rates, let's see, let me skip a little bit. Those who encounter such substances before their first birthdays seem to benefit rather than suffer from them. Importantly, the proactive effects of both allergen and bacterial exposure were not seen if it was a child's first encounter with these substances occurred before the age of 1. So we're talking about what children are exposed to before the age of 1. Our study shows that the timing of initial exposure may be critical. What this tells us is that not only are many of our immune responses shaped in the first year of life, but also that certain bacteria and allergens play an important role in stimulating and training the immune system.
My niece was like picking up and like eating dirt and crap, and my dad was like, "Get her to stop doing it." He's like, "No, let her do it." He was like, "Ah, that's not true." He's like, "Bullshit." Sorry, there's a kid in the room. My bad.
She can't hear. I've got a headphone in.
Thing that occurred to me is, I think it is pretty intuitive that exposure, an immune system's exposure to allergens, let's say, would build up an immunity or help build up an immunity during that first year. It's interesting, though, that it doesn't have any effect after that. You're getting exposed, a child being exposed to an allergen after their first year. It's not going to help their immune system.
Well, they didn't say that. They said it has very little effect. It didn't say it has no effect.
Right, little. We're talking about degrees.
Right. I mean, it'll still have an effect, just not as much as you'd like. So, she needs to be exposed to city allergies, country allergies, and seafaring allergies, if there are any.
Oh, she's already had all of that. She's getting all of that all the time because we travel around so much.
Excellent.
So she's getting farm allergens at the moment. Yeah.
That's the thing I wondered.
Yeah, she's been to the ocean side.
How long? I don't know, but I wonder how long the exposure has to be before the immune system builds a defense for it. A couple of days, a couple of months. And I also was thinking, for instance, Chelsea, I'm guessing you haven't lived with Chelsea somewhere where there are cockroaches? Because one of the main allergens when you're talking about apartments and cities, it's cockroach dust.
That's an allergen?
Yeah.
Their feces is, yeah.
Okay.
So I'm wondering, what if you marketed?
Yeah, I haven't, no, because where we are.
Are you trying to sell cockroach feces?
Where we are, it's too cold for them at the moment.
Okay.
So since she's been born, there haven't been any cockroaches in this region. So we are going into a city in 2 more months for another job, and it'll be warming up by then. So there might be some cockroaches around. Yay!
There you go. There's the next industry. Dust, different kinds of dust. And I've never had a problem with asthma or anything like that. I do get, a little bit of allergic reaction during pollen season, stuffy nose, and it goes away in about a day. I grew up in an apartment, but I also spent most of my time in my grandfather's home, and he had a garden and he raised chickens. So I got plenty of exposure. How about you, Dale? Do you have an allergic reaction to anything? Have your children had an allergic reaction to anything?
No, the kids, I guess there's mosquito bites with my daughter. Mosquitoes really, she'll get large welts and that sort of thing.
Yeah, I have the same thing.
Oh, do you?
Mosquitoes in Houston are horrible.
Oh yeah. Yeah, so she has that, but not too many allergies. It's interesting. I was trying to find more information on this, like to find the paper that they actually produced, because I wanted to learn more about how that works. So I'm thinking it's probably something to do with the adaptive immune system. The B and T memory cells, I bet, like if you have a flu, that's what will permanently recognize that pathogen and then fight it later. So if you get the same flu later, it deals with it quickly. I wonder if that somehow modulates these things so that when you have something specific, an allergen, or what would be considered to be an allergic reaction to something, that isn't modulated by that same process somehow, where you won't have the reaction if you're exposed to it. So I wonder about exposure time and everything else. Like you said, how long does it take for that exposure before it can modulate the immune system, so it recognizes things and deals with it appropriately. It doesn't um, overdo it and create all these symptoms. So I know, like with the flu, the adaptive immune system takes about 7 to 10 days before you get a specific response side. So maybe it's the same for that as well. But did you find a paper anywhere of the exact study other than the press release?
I've been looking through all the links in the press release, and I can't find anything at the moment.
I wonder if they've done more studies too. I wonder if this is a first.
It sounded like from the reading material that this is a overview of past studies.
Oh, okay. So epidemiological. They put it all together from a bunch of different.
At least partly, anyways.
Yeah, the only part of this story that was new to me, because I thought that was already established anyway, was that it's the up until 12 months thing. So I thought basically it was sort of, maybe till 10 years. That was my assumption before. As long as you're exposed, if it's only 12 months, well, good thing I'm doing what I'm doing.
I think this is an extension of previous studies, is what it is.
Mm.
Yeah, this is a study. Robert Wood, the Division of Allergy and Immunology at Johns Hopkins Children's Center. They said 147 children, newborns, Baltimore, Boston, New York, and St. Louis. We're talking about hospitals. They visited homes, measured levels and types of allergens. I don't see any other link, at least in what I printed out.
No, there's a link to hopkinschildrens.org and their allergy section, and a link to his personal, well, his bio page on their site. But I don't see.
So we would be born, I wonder, how would that work? We would be born, we're not born. Are we born with a sterile immune system? And that immune system then has to be programmed
Yes.
by the environment?
We don't gain the immune system from our parents. We have to create our own. Which is why we still have to get shots. Otherwise, the shots from our parents would be transferred onto us, or their immunology would transfer to us, but it's completely different. Unfortunately. If we could figure out a way to do that, we would eventually be immune to everything. For some reason, I want to say alligators are immune to almost everything. I swear I saw that
Sharks
story
don't
somewhere.
get sick.
Sharks?
Like sharks don't get cancer or anything like that.
What are those Komodo dragons? They've got some of the nastiest bacteria in the world in their mouths, and I don't think they get sick or anything else. I think that's one of the things people have studied, I think. Studied their saliva and how they can...
There's a Komodo dragon at the Houston Zoo. I saw it last weekend. Those things are awesome. I love those things.
Don't let it bite you, man.
Well, I think part of the... I don't know if they have like a gland or anything that keeps the bacteria, but I think it's part of the environment, like just the stuff they eat, and it just develops over time. That's my hypothesis.
Well, most bacteria is really good for you. It's beneficial from an epigenetic sense, and bacteria outnumbers us 10 to 1 with their own cells.
Right.
It's those nasty odd ones that can cause some issues, but unfortunately through antibiotics and everything else, these really widespread usage, it doesn't do a lot of good. It wipes out everything, the broad spectrum antibiotics, and can make us more ill in the future. So I guess when you need it, but you want to try not to use those antibiotics, right? Especially the broad spectrum ones.
Are antibiotics used on children under the age of 1?
I just saw a link on the Hopkins website that they shouldn't do that because it causes EOE, which I'm not actually sure what that is. Something esophageal, something. Allergic inflammation.
No, but I mean,
of the
they do
esophagus.
use them if they need to.
Yeah, if they absolutely have to, but
Something I've been doing with Chelsea since she was 6 weeks old, because she was a cesarean section, so she didn't get that good bacteria on the way out. So since she was 6 weeks old, I've been giving her, I don't know if you have it over there, but it's a probiotic anyway. We have Inner Health Plus for kids, and it's just a powder, and I just express a bit of breast milk and mix it up and give it to her, just a very small amount. And it's made, so I can tell it's made such a difference to how windy she is, because she was getting really painful wind on that for 2 weeks, and then 2 days, and one of the vaccinations was an oral vaccination for the rotaviruses. So I hadn't given her probiotics for those two days since then. I gave them to her again today, so that that could get through the digestive system, without anything being mixed up. And but yeah, again, last night she was really painfully windy again, so she's back on the probiotics as of today. So it doesn't matter if you have a cesarean. There are powders you can buy to make up for that.
I thought we weren't at that stage yet. I thought we didn't actually know what was good and bad. As far as...
Well, I'm giving it to her and she's happier, so that I think that's good.
Yeah.
Probiotics are really good. I think, unfortunately, something is better than nothing, but a lot of them, there's only 1 or 2 live cultures within it, and you need a live culture, and it has to, as you intake it, if you're intaking it orally, it has to survive all the acids and everything in your stomach, and that can be a huge challenge. But again, I think the conventional wisdom, as you were saying, Pamela, that it's better to take it, and hopefully there's some benefit there, and especially if you're seeing it, then that's great. But yeah, it's hard, because for it to survive that path, for sure.
Yeah, I'm definitely seeing it, and I mean, if it was me taking it, then you might think, well, it's placebo effect, possibly. I think it's going to work, therefore it does. But she doesn't know what she's having, so it's definitely not placebo. It makes a difference to my night too, that I'm not up all night with her while she's screaming, because it's painful. She has really painful wind.
Yeah, that's a really tough time too, where as a parent, and I've been through it myself, you have to try to think as rationally and logical as you can in a moment when there's screaming babies and they're hurting and upset, and you have to try to find the most logical course, and boy, is that's a challenge. I think that's the most surprising thing as a parent, right? Where you don't know how tough it is that first year of, especially for the mother, very little sleep, everything else.
Yeah, no one has any idea. I still have friends that compare to cat or something. Yeah, no. Nothing compares to this.
Aren't babies surprisingly resilient too?
Oh, I don't know. I haven't drawn a head yet, so I'll let you know. But hopefully I won't. But nothing compares to it, and you cannot prepare for it.
My sister-in-law and my brother were always like, well, they have their first kid, and my sister has their first kid right now. And they were like, yeah, we were really careful about stuff in the beginning, but he's surprisingly resilient. So we don't really care if he falls down a couple stairs or not. He'll be fine. But you're really nervous about first sight. So
I wonder, I know crying babies crying for attention, knowing the difference, learning the difference between when a baby is just crying for attention and they've really got a problem.
Well,
yeah, I can tell the different cries.
At least when it's like an older child, if they whine and complain, that's when they just want attention. But if they're silent, that means that they're sad. Like legitimately sad.
All right.
Well, yeah, I mean, Chelsea has a nappy cry. Chelsea has a I'm hungry cry. She has an I'm windy cry, help me get the wind out. And I'm tired, help me get to sleep And or if she sort of wakes up and there's no one in the room. I mean, we're always in the room. And where are you? I'm all alone kind of cry. So she has a heap of different cries, and they all sound completely different to me.
That's interesting.
My niece was visiting us the other day, and she said, "Oh, how did you know she needed a nappy change? How did you know she needed a to be fed and that kind of thing?" And I told her about the cries, and she said, "Oh, and some kids, they just cry and cry and cry for no reason." And I said, "No, children never cry for no reason. They just some parents know them, I think, sadly. You know, when you hear them just screaming in shopping centres and the parents don't really do anything about it, that's horrible, because they're trying to tell you something."
Yeah, well, some of those cries are because they want something and they're not going to get it. But yeah.
Yeah, that's when they're a bit older, but not babies.
Yeah, sure. Oh yeah, yeah.
Yeah.
Yeah. Moving on.
Oh,
to
I
our
cry
next-
when I don't get things I want. Yeah.
So liver regeneration, right?
Yes, that's the next story. Liver regeneration. I'm applying once again to my cheat sheet here, and this is research by Harvard Stem Cell Institute scientists at the Boston Children's Hospital. And every week I've been learning a new word. The new word this week is de-differentiation, forcing mature liver cells to revert back to a stem cell-like state called de-differentiation. So scientists have new evidence in mice that it might be possible to repair a chronically diseased liver by forcing mature liver cells to revert back to a stem cell-like state. The researchers happened upon this discovery while investigating whether a biochemical cascade called HIPPO, which controls how big the liver grows, also affects cell fate. The unexpected answer is that switching off the HIPPO signaling pathway in mature liver cells generates a very high rate of de-differentiation. This means that the cells turn back the clock to become stem cell-like again, thus allowing them to give rise to functional progenitor cells that regenerate a liver disease. Now, I know about pluripotent stem cells. That you take an adult stem cell, and that sounds like what's happening here, and you can turn them back into a pluripotent state. According to this article, though, this is something a little bit different. The researchers, led by Fernando Carmago, or something like that, happened upon its discovery while investigating whether a biochemical cascade called HIPPO, I already read that, moving on. The liver has been a wonderful model of regeneration for decades, and it's well known that mature liver cells can duplicate in response to injury. Even if 3/4 of the liver is surgically removed, duplication alone can return the organ to its normal functioning state. This new research indicates that there is a second mode of regeneration that may be repairing less radical but more consistent liver damage. The study highlights the tremendous plasticity of mature liver cells. It's not that you have a very small population of cells that can be recruited to an injury. Almost 80% of the hepatocytes liver cells can undergo this cell fate change. Now, he says, it might be possible to control HIPPO signaling to grow countless liver progenitor cells in a laboratory dish for transplant, which the team pursued and wrote about in their paper. They cultured healthy progenitor cells, transplanted them into the diseased mice. Over a period of 3 or 4 months, the transplanted liver cells engrafted, and the animals saw improvement of their condition. People have been trying to use liver cell transplants for metabolic diseases since the 90s, but because of the source cells, discarded livers, they were unsuccessful. With this unlimited source of cells from a patient, we think perhaps it's time to think again about doing hepatocyte or progenitor cell transplants. The observation is that mature cells differentiate comes from a number of related studies. I think maybe it's time that people have overlooked. I think it's something that people have overlooked because the field has been so stem cell centric. Dale, my stem cell man.
Well, I think that, I don't know, I'm probably dating myself here, but all I can think of is Mork from Ork. Does anybody remember Mork from Ork?
Oh, Mork, yes. Yes.
Do you remember they age backwards?
That I had forgot.
They come out of an egg as a fully grown adult.
Oh, that's right, yes.
Remember they age backwards into they're a newborn and then they pass away?
You're not talking about Mork and Mindy, are you?
That's it. Mork and Mindy. That's the one. Robin Williams.
Yeah, yeah. Okay.
So yeah, it's interesting that they can de-differentiate the cells. So just by, it looks like they're blocking this hippo pathway. I'm wondering how they're actually blocking that. If they're using this new
hypo pathway, but it's actually spelled hippo.
Hypo? Hippo?
Well, it's two P's, which I guess would mean hippo, but I don't know.
I wonder what that stands for. So, yeah, it's in the journal Cell, which is a pretty prestigious journal, that's for sure. So, the mature liver cells generates, and what's interesting is a high rate of de-differentiation, which is really, really amazing. And maybe that, somebody was thinking about that, and with the liver able to, regenerate itself and just seeing it, we've seen that for years that it can do that. Someone gambled on this and, can it de-differentiate as well? And it appears like it can. Now, one of the things that they said was, I think they're talking about this doing in vitro, and that always kind of scares me. When they do things in vitro and then put it back into the body, it's plagued with problems, so hopefully they won't have any of those issues. I think the ultimate would be to be able to instruct those pathways with like a viral target at some point where they can inject you with something, so that in your body itself you can reprogram those cells like through that CRISPR-Cas9 stuff, and just have it sort of regenerate in your own body without having to take things out and put them back in, because it's so messy when you do that, and it's fraught with environmental problems and epigenetic issues. So, but yeah, this is really exciting. This also reminds me of a story. Did we do the one of the teeth? I can't remember. Where they're regenerating teeth with lasers?
Wait, what? Tell me more.
No.
Oh, okay. It might be. I read a lot of articles. I can't remember where I see them or what's going on. But so they found out that they can regenerate teeth without putting anything chemically in your body. They use a specific wavelength of a low-powered laser, and they're able to basically take the existing stem cells that are within the gum line and regenerate a tooth from it. And it's amazing because, and this could get some FDA approval if you're in the US. It could happen fairly quickly because lasers are commonly used in dentist practices, so that's good, that's easy. And the other thing is you're not putting anything into the body, so for them to approve it, this research could go very, very quickly, and we could be in a position where all of a sudden, they'll take a tooth that's beginning to degrade and and basically pull it and regrow something in its place, like your baby teeth. So it kind of reminds me of the same thing. So the interest I have, though, is what wavelength of laser are they using, what power, and what particular process within those cells is it affecting to stimulate this and modulate this process. So much to learn.
They're doing this in rat molars.
They are.
It's an article on Slate.
That's the one.
Another one word.
It's very exciting.
Yeah. In this case, this particular study was designed to deal with chronic liver disease, as opposed to, let's say, somebody has half a liver and somebody else donates the other half of the liver and they regrow a fully functional liver.
Wait, can you do that? Can you take two separate livers and get one liver out of it?
If there's a match, I think, can't you? Isn't that what they do? They take a part of.
I thought they just took a part of the single liver.
Excuse me?
I thought they got rid of the original liver and replaced it.
Yeah.
Okay. Yes. You're probably right.
I know, like, livers can regenerate really well. Like, you can start a small little piece and then it'll generate to a full liver, but I don't think you can.
But if your liver is already damaged, then it's only going to regenerate from the state you're actually growing a crappy liver and back again. You need to take the old one out and put a healthy one in, or part of a healthy one in that will grow.
That's exactly what this study is addressing. Because here they're talking about working with the diseased liver and then blocking this hypo-hippo signaling pathway in mature liver cells. So I'm reading that to be they're dealing with a diseased liver and getting that diseased liver to function properly again. I don't think they're removing a liver here.
Well, they might not, but they're not taking two separate livers and combining them.
Right. That's true. That's correct.
And this is also another Boston Children's Hospital one, so this is like in child livers. I don't know what they would be damaged from, possibly from over-medication or originally damaged, I guess.
I'm just exciting that they can differentiate these things, and that's amazing. And what other organs will have this capability? With the same sort of pathway. So.
Yeah, if you have that hippo, I'm calling it hippo pathway, you can block the signal. I'm sure this particular study should certainly lead to more studies within that hospital, different hospitals.
So what do we have up next?
Up next, I'm going to jump ahead.
The operating room.
Well, I'm going to go to in our chat area, space. We've got some space people here. We've got Christopher with us. We got AJ. We got some space people. Let's see.
There's the baby.
I'm here.
How you doing, Christopher? We're definitely going to need you. Definitely going to need the space guys. Let's see. The first one I've got, we're talking about...
He's an engineer, not an astrophysicist, but he knows stuff.
I was going to say he knows more than me, but then that's not saying much. But we're talking about massive clusters of galaxies colliding into each other. A crash site 5 billion light years from Earth. They call it this conglomeration is creating one giant concentration on thousands of galaxies. This is really one of the most massive clusters we know of and one of the most complex mergers. There we go, mergers we know of. And this is from the Harvard Smithsonian Center for Astrophysics. And this was a talk presented by Reinout van Wuren. The Hubble Space Telescope previously captured images of the pileup called MACS J0717 plus 3745, my next password, in optical light. Now, with the orbiting Chandra X-ray Observatory and the Very Large Array in New Mexico, have observed the cluster in X-ray and radiolight, respectively. The new views reveal features that were not visible before, such as a bright and oddly shaped band of radiolight at the center of the cluster mergers. Scientists suspect is radiation emitted by highly energetic charged particles. The fact that this feature overlaps with an area of extreme hot gas, there you go, Pamela, more than 1 million kelvins revealed in X-ray data suggests here a powerful heat shock is acting as a cosmic particle accelerator. Such naturally arising particle accelerators have been observed before, most commonly with the remnants of supernova. But this particular natural particle accelerator may turn out to be one of the most powerful particle accelerations known. The observations suggest that the particles here are reaching energies up to 1 million times those in earthbound atom smatchers such as the Large Hadron Collider. In some ways, this cluster of galaxies is less violent than it sounds because it's happening very slowly. Most of the galaxies just fly past each other, but gas collides and gets shock heated. When the clouds of gas slam into one another, they warm up, creating this shock front from magnetic fields getting compressed. All right. Collisions in space.
Pretty rare, but they occur.
The interesting thing to me here is the fact that, I'm sorry, go ahead, Christopher.
As we look into the sky with our telescopes,
Cutting in and out a little bit there.
especially the ones tuned higher, may not be the greatest. Can you still hear me very well?
You were dropping in and out, but it's better.
Okay. Into the sky with visible light, we see a lot of things. As we turn rays and then we go into higher energy gamma rays, we see different things. And usually we can see at the higher energies basically the centers of the galaxies where all the giant galactic cosmic nuclei black holes are. And we can see quasars, which are actually entire galaxies. But this is interesting because I've never heard of a natural particle accelerator in space. I guess, to me, the particles are so spaced out that to have a magnetic field, you would have to have a magnetic field for an accelerator. To have a magnetic field be that stretched out, it must be a really condensed area, and all these galaxies so close to each other that they interfere. But what's interesting to me is that you would think that if the galaxies were randomly arrayed, you would think that the magnetic and electric fields would be kind of random, so you wouldn't really get a very large accelerator effect. But it seems to be an interesting part of space that when we look into the sky, we see a lot of activity.
Well, if it's happening at the galactic center, wouldn't that be more condensed than the rest of the galaxy?
Oh, yeah.
there's one part of this article says these when clouds of glass slam into one another, they warm up, causing the shockwave, where magnetic fields get compressed, and that causes particles to travel back and forth over the front.
What magnetic fields? Is it the fields from the individual? It's not the field from a particle. A particle doesn't have a magnetic field, does it?
Yeah, well, when you have gas from a star, the star is so hot that it usually separates the electrons from the protons. So you have hydrogen atoms mostly, so those are the protons, and they travel through space, and they're charged particles. But usually you have randomly spaced electrons as well, so the electrons and the protons kind of cancel each other out on the whole. But maybe there's some kind of special, you're talking about shock waves, maybe those shock waves are only really affecting the protons, and the protons are all building up, which sets up a very large positive attraction force, which has an electric field associated with it. So that could be.
There's another story coming up about magnetic fields and black holes, and I haven't taken a look at it, but it seems to be in the same realm of weirdness.
No, I can only jump to that because that's another story I have. I
And then we
will
can
read
get
some
into
words. I'll
the
read some words from this particular piece of paper, my cheat sheet, and I have absolutely no clue what they're talking about. Now, this is super strong magnetic fields can affect a black hole's gravitational pull. And this was written by Amy. I thought she might be popping in here. She's at a space museum today. So I'm going to read what she wrote about the articles, because she can probably explain it a little better than me. It says, black holes are cosmic powerhouses, ruling their surroundings with a powerful gravitational pull. Despite this tight rein, there are some forces at work around these cosmic monsters. A new study by the Max Planck Institute for Radio Astronomy and Lawrence Berkeley National Laboratory shows clear evidence that magnetic fields play a huge role in the dynamics of a black hole. A team of researchers studied dozens of black holes and concluded that the black hole's pull was equal to the strength of the magnetic field. Sometimes black holes are messy eaters, and when they gobble up surrounding interstellar gas, part of it is ejected in the form of outflows or jets. This new study concentrated on black holes known to produce these types of outflows. The radio emissions produced by the jets allowed researchers to measure the surrounding magnetic fields and determine the correlation between the black hole's gravitational pull and the strength of the magnetic field. Scientists have been studying state-of-the-art computers which simulate these conditions, and computer models have confirmed that when gas falls back into the black hole and brings with it a strong magnetic field, the magnetic field near the black hole strengthens until the two balance out, ultimately altering the behavior of any gas surrounding the black hole. Interestingly, researchers observed that the magnetic field surrounding black holes is similar to the field produced by MRI machines. The field is observed is roughly 10,000 times stronger than that of the Earth. The field strength measurements near the black hole were calculated based on what portion of radio emissions were absorbed at different locations near the base of the jet. How powerful and how luminous a black hole jets are is determined by the length of the magnetic field near its horizon. This study alters our view on exactly how powerful we think black hole jets can be, since these jets have an impact on the galaxies they belong to. They may have a larger impact on their environment than originally thought.
Only 10,000 times Earth's magnetic field? That seems low. I would think it would seem low. It's a black hole after all.
I wonder. What's amazing about that is really that the gravitational force is so strong to me, because if you look at the attraction of the Coulombic force, and when you have charged particles, they're probably measuring charged particles as they travel out of a black hole. Usually charged particles are dominated by the magnetic and electric fields. And the fact that the gravitational field is even on that same order is amazing. You know, if you look at the gravitational constant, I'm trying to remember, it's something times 10 to the, was it negative 19th or something like that, and there's like 10 or 20 or 30 orders of magnitude. I'll have to look that up between the two forces. So the Coulombic force is much stronger. One of the things I liken it to is if you fall from a building, you know, people say, oh, I'm afraid of gravity, you know, it's going to kill me. Well, no, the gravity is nice and easy. It lets you fall. It's the Coulombic forces at the bottom of the particles interacting with your particles that actually would kill you. Gravity is nice and easy. So if you were to be next to that black hole, you would probably get ripped apart pretty easily. Just your not only gravitationally, but all of your electrons and would be sucked out of your body probably too.
But extremely slowly and painfully.
I don't know what it would feel like to have electrons sucked out of my body. It would probably be painful.
You probably wouldn't notice, really. They're subatomic. Can your body feel subatomic particles being bombarded against you? You can feel them ripping through your
It
tissues.
could be happening right now.
Well, yeah, it is happening right now. That's a good point.
Yeah, I could probably deal with quick and painful. Slow and painful, not so much.
I'm open to new experiences, so.
Just, I hate to play, you know, the woman card, but you guys have no idea what pain is. I had no idea what pain is until 2 months ago.
I've been told kidney stones are very similar, but I have no experience in that either, so.
I have.
I don't know, have any experience in that either, but yeah, I had no idea. So you have no idea.
Well, the difference is we're talking about with something like a kidney stone, I think, or when you talk about the kind of pain, I think for a brief moment, the pain I feel may equal that of a mother going through the birth process. But in your case, you're experiencing that pain for a period of hours.
Or days.
Pam, did it subside right afterwards?
I think we just lost audio.
I think she's trying to unmute.
Yeah. There's a baby in the room, so that's probably why. But yeah, I don't think I don't believe you would be able to feel your electrons being ripped out of your body. Because as soon as they do that, then your body doesn't function anymore.
It would have a lot of. It would mess with your nervous system quite a bit.
Well, it would mess with the atoms, which would
So you
not
don't think it'd be
function
painful?
the way they're.
I don't know. It might just give you a tingling sensation, or it might hurt a lot, or it might feel like nothing. I guess if
It's
you
all of
get
them at
exposed
once.
to
I'm saying you're dead.
I remember reading a story of some of the people after Chernobyl that were cleaning up. There were about 30 people that died from Chernobyl that immediately ran to the reactor and almost were trying to put it back together in a way. And they didn't die for a few days. It took them a while. So I would guess if it's anything similar that you might, I don't know. I don't know if the electrons would get straight up sucked from your body, or if they would just kind of get pushed all over the place in your body. So if it's like the radiation, you may not feel anything, and it might be a slow death. But then again, if it sucks all the electrons out of your body because the field's so strong, then maybe you would die quickly.
If it sucks all of the electrons out of your body, wouldn't the chemical bonds no longer function, and so you would just break down?
Pretty much.
Would this kind of cause mutations in our DNA?
Do you want superpowers?
Well, no. I mean, that's kind of how neutrinos kind of ripping through our DNA create mutations on Earth, and we have different kinds of...
Wait, I thought neutrinos passed safely through everything.
Do they?
Yeah, neutrinos don't hit anything. That's why they're so hard to detect.
Okay. Maybe it's radiation.
There are people that live, I don't know how far away from Chernobyl, but in that area, and they choose to live there even though the radiation levels are very high. And they've been living there for a number of years. And I remember a study about both the animals and the people who live there, and their cancer rates so far were not dramatically different from other populations. But I don't remember all the details. But the word I remember, it wasn't dramatically different. Now, I don't know about mutations. I don't know about if their children are born with more mutations or not.
Yeah, there was a statistically significant thyroid cancer, and then everything else is in the noise.
Right. Yeah, I remember hearing that too. I think it was on like a Discovery show or something like this.
I can think of two people. What about, Madame Curie? Her exposure over the long period of time, it was slow in her particular case.
I don't know who that is. It sounds familiar.
She discovered radium.
Okay.
And she died from radium. But I was just thinking, what if she was going to get cancer anyway, regardless of her career choice? How do we know that the radium is what gave her cancer?
Yeah. But aren't the...
Because if we just assume...
Yeah, but isn't it that the scientists that discovered the properties of uranium and whatnot died of cancer?
Uranium wouldn't kill you.
Probably.
Unless, you'd have to eat it, and then it would kill you with the metallic, the metal toxicity.
Well, what if it was in your side drawer desk
You don't have exposure.
a decade or so before you realized what it did?
So when you think about radiation, the half-life is related to how potent it is. So the shorter the half-life, the more potent the material. And uranium's half-life is billions of years. So it's the ones that'll be damaging are the isotopes, like the iodine, which was the worst during Chernobyl, had I think an 8-day half-life.
Right.
And then you get up into the decades, and the ones that are 30-year half-lives are still there in Chernobyl, but they're much weaker than the ones that were there before. So by now, what's left is just this low-level radiation that we don't know what to do with. It's kind of, it's not good, but we don't know enough about low-level doses to really understand if it's really hurting anyone or if it's really benign.
What are the particles? It's like alpha particles, beta particles, and gamma rays?
Yeah. So
alpha particles can be just bounce off your skin. Beta particles you need some protective layering for. I forget what the rest is.
Yeah, the alpha particles are actually helium atoms. that are being shot out, but they're so big that they get stopped by just about anything. The beta particles are electrons, and they're being ejected out, and they take, if you have a piece of paper, it should stop it, but you don't generally clothing or skin will stop the beta particles. Then you have gamma particles, which are actually, those are just photons, like light photons at high energies, and those you can't really stop. There's a famous thing where they say that if you have a beta, alpha, and your beta, alpha, neutron, and gamma source, which one should you put in your pocket? Which one should you eat? Which one should you just put in your hand? And which one, forget the exact quote, but generally you understand, what it penetrates through. So for the alpha particles, you can hold it in your hand. For the beta particles, you put it in your pocket. And for the neutrons and gamma rays, you can eat it because they pretty much will travel straight through you, or straight through lead, or straight through whatever. You can't stop them very easily. Good news is they might travel right through you and then not interact with you. Most of the uranium is also an alpha emitter, so it's easily stopped. You may have remembered a few years ago when that spy died. He died from polonium, which emits alpha particles, which he should have been safe, but what happened is they fed it to him in his food. So he ate it, and its half-life was pretty short. I think polonium's only a few weeks, or maybe even shorter, and he died.
How much would that have affected the people that dealt with them, people who performed the autopsy, for instance?
Only if they had eaten it, because
Only if they ate it too.
Of your lungs and your stomach, like if you inhale it or eat it, there's some tissues in the body that our skin is basically a layer of dead skin and then a layer of living skin, and it's thick enough that it doesn't affect you, but in your lungs it'll affect the tissue in there. I can tell you the half-lives of all these things shortly. So it looks like polonium-210, which is what they used, was a 138-day half-life. So they fed him a sizable amount of that, whereas, let's see, is it radium or radon? I forget.
Radon is the gas in people's basements that they have to worry about.
Yeah, I think that one is also pretty weak. So, let's see, we have radium, and radium's half-life is, there's one that has 3.6 days, radium-224, and there's some other ones that have, the next most potent one is a beta emitter that does 5.75, but the radium that's 3.6 days is an alpha emitter.
So a lot with human physiology is exposure time, frequency, power, the density of the tissue, all sorts of factors. Ionizing, non-ionizing. So non-ionizing radiation generally is fine.
Is there any no, probably not. Is there any radiation generated when there's like combustion and stuff or anything like this, or like when you happen to be skimming through the atmosphere on some sort of big UFO-shaped object like NASA's testing?
Is that a segue into the next article, Patrick?
I was attempting to. It wasn't quite working as well as I was hoping.
All right, we'll jump into that. That's your low-density supersonic decelerator. That one I will try to screen share on that article because it's an interesting-looking donut-shaped thing. And this is an article also written by Amy in Space Flight Insider. There we go. The big donut-shaped looking thing.
I like how it's built by number.
Oh, it's little numbers on the side.
Hey guys, I'm sorry. I have to get going right now. I have to run, and I'm missing the most exciting story, unfortunately. So I didn't want to be around for this one, but I'm going to try to get to the next one of these, and appreciate all you folks, and we'll see you next time.
Great having you on.
See you later.
See you later.
Yeah. All right. NASA has developed a new innovative vehicle capable of landing larger payloads in environments such as the thin Martian atmosphere, and that's what this Low-Density Supersonic Decelerator is, a saucer-shaped rocket-powered vehicle now being completed and ready for testing. And I think the testing has been put off till next week. The first experimental flight test will record the performance of the new breakthrough technologies beneficial to the success of future Mars missions and even for human exploration. The vehicle was constructed at NASA's Jet Propulsion Lab in California. Assembled and prepped at Kauai. That's in Hawaii, isn't it?
Yep.
Kauai.
Over the past 3 weeks,
no E. I think it's just Kauai.
yeah, it's AI, Kauai. Over the past 3 weeks, the vehicle has undergone a series of tests in order to ensure it will be ready for the test flight. Supersonic Flight Dynamic Test Vehicle #1 and arrived at the Navy's Pacific Missile Range Facility on April 17th. Since then, we have, and this is Mark Adler, the project manager, been preparing it for flight. Last big assemblies occurred in April 30th. During the initial test flight, a large helium-filled balloon will be used to evaluate the test vehicle, elevate the test vehicle from the facility up to an altitude of 120,000 feet, where it will free fall for a fraction of a second before its 4 rocket motors will gyroscopically stabilize the vehicle. They hope. After about half a second, the Star 48B long nozzle engine will ignite and send the vehicle shooting back up to 180,000 feet to the edge of the stratosphere at speeds up to Mach 4. At this point in the flight, the saucer will perform a series of automated tests, and as the vehicle craft slows to Mach 8, the first of the 2 atmospheric braking system technologies will be deployed. Our goal is to get to an altitude and velocity which simulates the kind of environment one of our vehicles would encounter when it would fly in the Martian atmosphere. We top out at about 180,000 feet in Mach 4, then as we slow down to Mach 3.8, we deploy the first of the 2 atmospheric braking systems. There's a diagram here. There's a little diagram. I can't make it any larger. But, the atmosphere.
Control plus.
Huh?
Control plus on the keyboard.
Control what?
Plus.
Oh, plus. Good, great. I thought you said fluff.
No, plus. There you go.
Don't mind me.
That'll make the text bigger. It won't make the image bigger, will it?
Oh, it won't make the image bigger. Okay.
It got a little bit bigger, but not really that much.
You can keep hitting it.
There's a picture of a blowfish below that. I don't know, that's interesting. The atmosphere on Mars is very different from the atmosphere here on Earth. Thank you so much. The thin Martian atmosphere is a tricky environment. It has too much atmosphere to permit the use of rockets to land large payloads on the surface, like is done on the Moon, but too little atmosphere to find large payloads with friction or parachutes like we can have here on Earth. in order to outsmart the Martian atmosphere, a combination of parachutes and rockets or airbags must be used in order to land large payloads. It's not practical to test these technologies on the Martian atmosphere. The upper layers of Earth's stratosphere are a practical substitute. Let's see. NASA has 6 potential launch dates for this test flight beginning on June 3rd, and I know that's been delayed. And I think the next window, I'm pretty sure, is next week.
No, it's actually tomorrow. It's in
tomorrow.
One day, 16 hours and 44 minutes.
By the calendar, tomorrow is next week.
Okay.
I assume you're going to watch it live there.
I'm going to try.
Ooh.
You can watch it? It's going at Mach 8.
Well, you can watch it launch, and then then the rockets fire. It was funny, I saw on one of the websites in Hawaii, they were warning them in case there were any UFO reports.
Oh.
UFO reports.
Yeah, but wouldn't it be convenient if there were UFOs that day and they had an excuse? Chris, didn't you work at JPL for a bit?
Yeah, JPL is a great place. I spent a summer of 2012 there. I worked on what they called the control data system, which they have what's called a deep space network, and it transmits data from various satellites and spacecraft to various places on Earth. So I did some software work on that.
What kind of program was it?
Probably C.
They were using something called. They're using a database along with Java. I'm trying to remember the exact name of the database.
Chris, you're kind of muffled. Can you get right next to the mic?
Better now?
Yeah, lots better.
Okay, yeah. Yeah, but they had some kind of a database server that they tied in with Java, actually, was the main programming language there.
I hate Java.
Yeah, this would look like a real interesting test, though, to see this thing it's going to be dropping down, then it's going flying back up, and then dropping down again.
I can't. I was talking to. Wait, is this purely a JPL design and build?
Looks like it.
Okay. So I was standing
next. On it.
I was standing next to some material engineers at work last week, week before, something, whatever. And they were talking about cracks in some sort of material for heat dissipation. I was wondering if this thing was going to crack up on them or not.
Well, they said in the article it's not guaranteed to succeed. Now, I don't know what the odds are, but that would be, they got to be pretty confident. And that would be a pretty spectacular.
Tests like this, they want it to break.
Yeah, that's
they want a certain degree of success, but they also want it to break so that they can figure out why it broke, and then they'll know how to prevent it in the future. Like if they follow their models and their models work fine, then they weren't pushing the boundaries like they were supposed to do.
I think it's useful. I've heard in the past they talk about balloon reentry. So in the past, you need a heavy heat shield that's ablative, and I think this idea was maybe a couple of years ago. They said you could use a balloon rather than this heavy heat shield, so you'd save weight. And if they can just show that this works, that would have pretty big impacts, even if for companies like SpaceX. SpaceX. I don't know if you saw the unveiling of the Dragon.
V2.
Yeah, it's not the coolest looking thing, but it's got some good technology in it.
Well, if this inflatable reentry shield works, then they could put that on the Dragon and then carry more cargo and people up and back and forth to the space station.
Mm-hmm.
Yeah, there's a in Building 13 they're working on inflatable. Actually, I'm not quite sure what the end goal is. They're working on inflatable structures for space travel ships and whatnot. Their first test didn't go so well. There's a manufacturing flaw in their design or something, and it was supposed to be like a 3-month like stress test of it being inflated, and I think it popped after like 8 hours or something.
Oh no.
Yeah.
I know I've heard they wanted to do a balloon on, is it a Titan? A balloon on the atmosphere of Titan? Hot air balloon? Because the atmosphere is so thick you could have a pretty good balloon. I know someone else who actually wants to do a quadcopter on Titan. They got NIAC money for that recently because the atmosphere is so thick. But yeah, balloons have applications in certain parts of space.
I don't know why you would want to use a quadcopter on Titan. Such a waste of energy.
They were saying that you could actually take 2 pieces of cardboard paper and fly in the atmosphere on Titan because the atmosphere is so thick. So I guess it would, to me, I think of quadcopters on Earth, the battery's done in 15 minutes. You've got to pack up, but maybe the conditions, the atmosphere is different enough that it would be a feasible spacecraft that could fly from point A to point B easily. The other idea,
you'd adapt the vehicle to the atmosphere you're dealing with.
Mm-hmm.
Right.
And it would be a good idea to have different designs for different kinds of vehicles. In this particular case, I don't know how much you could test this this LDSD here on Earth. Is it pretty much, let's see what happens when it's up there?
Well, the reason they're at that altitude is to it's a facsimile of Mars atmosphere, because Mars atmosphere is 1% that of Earth, and so they can't test it at ground level or like on a rocket sled or something. They have to be up in the stratosphere to actually get their correct data for what they want to use it for.
Because it's obviously a very expensive thing to construct, and I don't know if is this the only one. If they have 2 or 3 waiting in the range, so that
This is the first of 6 tests, is it?
Okay.
I thought it was 6. Maybe it's not. It might be 3 or something. But they usually do multiple tests of these things. I don't know if this is for manned payloads or not. But if it's manned payloads, it's super rigorous testing. Manned payloads, it's significantly more engineering and development time, R&D, than it is for like a satellite or a probe.
How are you going to talk that guy into trying it? Okay, we're not. This is our first model. Maybe it works. Maybe it won't work.
That's more of a Kerbal Space Program way of going about it. I should pick that game.
So one of the big problems with the reusability of the Dragon is, in fact, the heat shield. So if they got something like this working, I think that should send to you. The improved heat shield materials are key to Dragon reusability. So if they could just have some kind of giant balloon that they wouldn't have to replace, well, they would probably have to replace it. Maybe it'd be cheaper. So I think.
Well, yeah, but the Dragon capsule is all about having one single unit that's always ready to refuel. They wouldn't want to have to replace a part on it. I suppose it could be part of the refueling process, but
yeah.
If they could have something that could be collapsed back in, like a parachute style-ish thing. It still retains parachutes on the vehicle.
Yeah. I think there are, if this technology works, I think there will be applications and people that will want to use it. But I think this was kind of just a crazy idea, and they're going to test it and see if it's really practical. Because to me, I
Right.
think balloon flying through the atmosphere at Mach whatever, I would think it would pop or burn up, or I don't know. It just doesn't seem.
Well, it's not about, it's the surface area, right? A larger surface area means heat dissipation is spread out or whatever, right? So plus you have a gas that's filling it up, and that's helping dissipate the heat as well, right?
What about
Yeah.
where it lands? How well can they control the landing site?
Oh, did you see the YouTube video?
Of the second
V2?
capsule?
Yeah, the V2. It looked
They say it can land like a helicopter anywhere.
right, exactly.
Are we talking about the LDSD, or are we talking about something else?
We're talking about both. The LDSD, that's the, what did that stand for? It's the
That's the low-density space something.
deployment. I totally don't have the link in front of me.
It's the low-density supersonic decelerator.
Ah, yes.
Decelerator. That's what I was wondering, if they can, obviously they have to land it, because then they want to inspect it to find out, exactly what happened. And it's
Right. I think it'll actually crash into the ocean or something.
so they're going to rely on onboard instruments.
Yeah, it's all on board. They're gonna have a telemetry that that's coming off of it, live telemetry probably to some ground station.
Well, can you
Possibly some Navy
imagine?
ship.
Can you imagine the alien stories we're going to get when people see this big donut thing flying down from
Oh, dude,
space?
there's a YouTube video somewhere of these people driving past Kennedy Space Center when they were testing Morpheus at night or like at dusk or something. They thought it was an alien spaceship like probing Kennedy or whatever. It's hilarious, like morons. But low-density supersonic decelerator. I mean, they're also building supersonic parachutes at Johnson. I'm not sure if they've tested those or not. But the heat shield they're using for Orion is supposed to withstand 4,000 degrees Fahrenheit when it's coming in. And that's at like 20,000 miles per hour or something. Frankly, they just need to figure out a way to slow the ship down, and they won't have to use a heat shield. But it's like the episode of Stargate where the alien ship is in orbit and they need to destroy it, but it's got great force fields, and so they decide, and it stops all explosions, but it can't withstand a little heat. So they just crash it into the atmosphere.
So this thing in the atmosphere, we're talking about Mach 4 to Mach 3.8. That's pretty fast. But,
Well, yeah, a plane can go that, but like was it Mach 3.8 or was it Mach 8?
No, it's Mach 3. It was between Mach 4, I thought, and Mach 3.8.
Yeah. Seems like that would rip apart a balloon.
Well, it's like a Kevlar reinforced polymer or something or other.
Right.
And it's you have to remember that it's not a balloon. It's supposedly designed to do this. We'll find out. We'll see if it pops immediately or something. But and usually when it does pop, it's like a manufacturing defect. Like, oh, we'll look back at it and they'll see like, oh, this seam ripped because the stitching wasn't secured, or the stitching was frayed, or the heat seal on it was not properly done, or whatever. Like, there's so much. Like, I'm always at these engineers' desks, and they're always complaining because, like, who's ever building the actual vehicle or whatever, they do it wrong. Like, it's not to spec, or like they keep having to rebuild everything. Everything is rebuilt like hundreds of times when they're trying to get these things built. It's like, oh, they used the wrong type of solder, or they drilled these holes and they didn't properly measure them, so they're like off by like a micron or something, or they tapped the holes wrong, so they have to be rebuilt, or something like this. And it's like, that's all I hear every day. When I'm going around fixing computers, is like, oh, they did this wrong, so they have to redo it, and so they have to go talk to this guy. So yeah, it's like this one little component or whatever, they made this one error on this one single piece, and it's like a 5-day turnaround discussion thing with like 50 people going up the chain or whatever. It's like, that's NASA for you. And that's
JPL told a story of a spacecraft, that the Cassini spacecraft, and someone was getting a new, it was some kind of wire, and the wire was supposed to have no oil on it. I guess the wire typically had oil on it. And they made the order for it, but the person messed up, and they shipped them the wires with oil, and then they put it in the vacuum chamber, and they coated the vacuum chamber with all the oil that was on it, and just like delayed the Cassini for like a whole bunch of days because they, and everybody was trying to blame it on someone else. So whose problem, whose fault was it that this stopped us or damaged our vacuum chambers?
Like it all comes down into the wording of the contract. Like I was fixing this one lady's computer, and she was just like zoning out to this conference call she was on, and she was like, she was trying to explain to me what the conference call was about. Oh, they're trying to figure out whether or not they actually have to do this thing, and whether or not the contract says the contractor may have to do this, or if they're whatever. And it was like, it turns out that if they do have to do it, it's like a $150,000 mistake or something. But if they don't have to do it, then they don't have to do it. But they just go on and on and on trying to. Yeah, that's NASA.
Yeah, I wanted a couple of stories I wanted to go over with. Pamela's here. Pamela's studying to be a lawyer, and I've got.
Pamela's always studying to be something that she's not.
Yes, very much so. Pamela, how did the test go when you were breastfeeding your child? You had to go to a law exam.
Yeah, I sat outside with her, with my baby, and I expressed enough milk that I hoped would last. I thought if she needs any more, the invigilator and the person supervising, there's two of them. One would stay in the room, and the other one said that she'd come and get me to come out, supervise that I wasn't cheating while I breastfed, and went back in. But it turned out there was actually a little bit of milk left over, so it all worked out fine. And then I did that four more times this week. But the first one was a 3.5-hour exam, so that was the big one that I was really worried about. But the others were only a couple of hours each, so it's fine. You can have a baby anytime.
That's interesting.
So how was the test?
Sorry.
No, the test. It was more the baby I was worried about.
I've got a couple of stories, but I'm not even going to bother reading them too much because the main thing is the issues that they raise. And the first one is Google Glass. And Google Glass has been getting a lot of bad press for the most part in the press. A lot of people worried about it, worried about privacy issues and all this other stuff. There's an article in New York.
Just a bunch of glass holes, right? So I mean.
Yeah. But I mean, this kind of technology, wearable technology, hands-free technology, that's going to be a tremendous teaching tool, tremendous for anybody who's trying to figure out how to do something. And I'll just read briefly from this article. It's in the New York Times, and there's a doctor, Dr. Selina Parakai, an orthopedic surgeon at Duke Medical Center, and he has Google Glass. He puts on his Google Glass before he's getting ready to go in for an operation. And he gave the internet-connected glass a voice command to start a recording and turn to the middle-aged motorcycle crash victim on the operating table, and then he did his operation. The main thing is that as he was doing his operation, the image using Google Glass was going to a group of medical students in India, so they could watch the operation and they could learn from it. Just so many applications. You know, you're in your backyard. AJ, you're working on your car. You're trying to fix your car. You run into a problem. Okay, how I got to turn? You using Google Glass. You contact a friend of yours, an expert, somebody who can help you out. They can see exactly what you're looking at, and they can help you right then and there.
Google already does this. It's called Google Helpouts or something like this.
That's what I was about to bring up. Even
I tried to get into it, but they didn't accept my application.
Even if you didn't need that, if you're just like I'm under the car and I need to just check out a YouTube video real quick, I can just like call it up without even moving, and that's like really helpful.
I mean, people who are worried about privacy issues just don't wear them. That's fine. But something that I would have appreciated this week is as I was doing exams and things like that with uni. Has anyone else here done some Coursera courses?
Yes.
Okay. Now you know that you can get the verified certificate. Is it the verified certificate or just the freebies? Yep. Okay. So for those who don't know, your webcam is on while you're doing your quizzes and things like that, and it takes a photo intermittently and all this to verify that it is definitely 100% you taking the exam, because you have to set it up with a photo identification that matches your face and everything like that prior. Why can't all universities do that? I had 5 exams in the last week with a newborn baby, and if I could have had Google Glasses, I could have done the exam from home, and they could have seen what I was seeing to make sure that I wasn't cheating, you know, that I wasn't looking at any books or anything like that. One of the exams was open book, so that wouldn't have mattered, but the other 4 exams were closed book. So why not implement that? Why not say, okay, all students who want to, you can do your exam from anywhere in the world over the net, and we can watch and make sure you're not cheating.
There are some online tests and such where when you start taking the test, it's got like some proprietary software hooked up to it so that it completely locks down your computer and you can't do anything else while you're in the test mode. There is that. I mean, I know. Like,
no, but you can have physical.
Yeah, like why every university doesn't do it? Because they're stuck in their whatever and they don't want to implement it for the most part. It's just a bunch of old people that don't know any better.
Go on.
I was recently listening to, I believe it was NPR, and there were 3 speakers, and they each had their own method. There was someone at MIT that was arguing for that you still needed the personal connection, the personal come to the classroom, and that people can help you. And there was a person from India who had something that was, it almost sounded like the Khan Academy. Or no, he was from South Korea, that's what it was. He had a university where it was, I think, the first completely free, fully, I guess they had accreditations of some type, university in South Korea, and he was arguing that you don't need to have that personal connection. And then there was, I think, yet another person who was arguing for something else. But I found that interesting, that different, universities are such that they make, well, they have to make money as well as teach in a way. So whenever money's in the equation, I think it might be easier for them to get more money out of you if you travel to the school, but it could also
think it would be the opposite.
I only travel for exams. I'm doing mind-based education.
Okay.
But I had to go to 5 exams in the last 2 weeks, which was an hour each way travel plus the exam itself with a newborn baby. And the reason I had to go was to make sure I wasn't cheating. And I'm just saying that could have been circumvented if I was wearing Google Glasses and had done the whole thing over the internet, and they could have, 1 or 2 people watching, 100 people on a screen, and make sure that they're not looking at books, or they're not looking, at a past exam paper with the answers or something, and that I'm only looking at the exam.
Well,
or my baby.
I mean, there's a few things with that. I mean, Google Glass, it's a static camera, right? It's not tracking your vision. And so it's looking wherever your glasses are pointed, but your eyes can go side to side, up and down, like left and right. So like your husband or your partner could be in front of you, just barely out of the range of Google Glass showing you answers. But if you had like 3 or 4 cameras pointed at you all on the stream, then yeah, sure, that makes sense. But
there's rumors that eye tracking is
Let's
coming.
do that.
And that kind of brings up a privacy issue there. If it can track your eye, it can probably do a retinal scan.
no, it's a lot harder to do a retinal scan. You need a really high resolution camera to do a retinal scan. I know people who are working on eye tracking, and to do the eye tracking, they use a really low-res webcam, and they just do it via contrast detection. They're detecting the outside of your eye and the white parts of your eye and your pupil moving around in that space.
Mm-hmm.
It has nothing to do. It's like maybe the sensor is like 60 by 60 pixels or something, and that's all it needs to figure out the contrast. So they do it that way, so that's really low cost. They could use a higher res camera, and it might give you more accurate results, but you really don't need that, because they can do all this algorithms and whatnot and predict all this stuff.
Well, Google has a patent already for direct retinal scan displays.
That's different though. That's projecting something into your eye.
Well, the diagram on the patent shows a pair of glasses. I just threw those links in the chat room.
That sounds more like, that sounds more like a Cowboy Bebop heads-up thing. Or no, was it Cowboy Bebop or was it Outlaw Star, who has this little thing that you put right here and you flip it and it's like points like a laser beam in your eye and it's a full heads-up display.
Screen share.
Yeah.
I don't know how far I can turn down. But the question I would have is, what do you want to do with that retinal scan? And can the precision really be that good?
Well, I mean, it's Google. They're all about
this is not a scan. This is a projection. And it says scan, but it's not.
Right.
It's not
It's
scanning.
a display. You're right.
But this was back in 1992 that they made this patent. I mean, it's been...
Google had... I don't know if they had Google Labs in 92.
Yeah, but, I mean...
I didn't even know you were around in 92.
They probably bought it.
Oh, yeah, they probably did buy it.
They're collecting data on everything else about us, everything we do. If they get our retinal scans, then, I mean, it's pretty much over.
No, I don't. This has nothing to do with scanning.
Well, I know, but this is in 92.
It's the scanning uses micro-machined mirrors, electro-optic. It's scanning the laser up and down the back of your eyeball. It's not like your cones and whatnot. It's not actually scanning your retina itself.
Well, they could do facial recognition if they really wanted to. I mean,
they do already. It's just not that great.
I think for a while they had a policy that anyone developing apps on Google Glass couldn't do facial recognition. But
yeah,
I heard they dropped that policy recently.
Okay. Yeah, I think I remember hearing about that.
Yeah,
I don't care. They can scan my eyeballs. Just let me take my exams at home with my baby.
I'm going to go into the next story I had, which is actually kind of related. And this is a law. We're dealing with a law school here. I'm not going to read the whole thing. But it talks about using computers to influence the law. The Fourth Amendment of the U.S. Constitution protects citizens from unreasonable search and seizure. Ever since the Supreme Court 1967 decision, the right to be free of unwanted government security has been tied to the concept of reasonable expectations of privacy. Now, these researchers at Columbia Engineering and the University of Maryland Francis King Carey School of Law, they published a study that examines how advances in machine learning technology may change the way courts treat searches, warrants, and yes, that's what I think, and policy issues. One of the big questions under debate is whether police should be required to get a search warrant before tracking someone's location. The traditional answer has been no. You have no expectation of privacy in public movements, and 30 years ago the court upheld the use of tracking devices without a search warrant, but in cases that were where it was only used for 3 days. So when we have the court case, we're talking about 3 days of tracking someone. It helped answer these questions. The legal academics they developed, here we go, the mosaic theory of the Fourth Amendment, which holds that a large enough collection of data is vastly more revealing than just the individual parts. Court of Appeals holding that the long-term surveillance, 4 weeks in this case, was a search protected under the Fourth Amendment, that it expressed an innate picture of the subject's life that he expects no one to have, short perhaps of his spouse, and therefore should have had a warrant. So what we're talking about is the length of time you need a warrant, and these researchers are saying that they've developed a model so that if you look at your tracking for 7 days, that's all it takes. For 7 days, you can pretty much tell the habits of the individual that you're following. And with this kind of technology, you don't need surveillance for more than 7 days. Okay, Pamela. One, I know you have a private detective agency. You have tracked people, probably. What's your opinion on how long it takes to track someone to get a fairly good idea of what their habits are, and 2, studying for law, what do you think this business about not getting a warrant for putting a tracking device on someone's car?
No, you should always have a warrant for anything more than 3 days. I think actually for anything 1 day, anything. The reason, basically, as a private investigator, I don't really have access to information any more than the average person. It's just that I've been screened and trained legally, so I'm allowed to do what I do. Right? So, just for an example, if you're I don't know about everywhere all over the world, but basically here, if you're tracking your spouse to see if they're cheating on you, and then you use that in court, you can't actually submit that evidence, but I can. So if you hire, you should always have a warrant. Go on.
No, sorry, you just froze for a little bit. But so you as a private investigator can get a warrant?
No. I just mean by law, you need to have someone qualified to be. Anyway, so I'm just saying by the same token, I think they should always have a warrant because that qualifies them, right? Because you get the warrant from the judge. The judge says, yeah, I think you should go and check that out, and you get the warrant. We're talking about qualified and trained people, make sure that they're for tracking people. But tracking people, you only need for 7 days. I don't know. No, it varies. Sometimes people can take a month before they do something naughty.
I think the part of the research where it's the 7 days may be specifically because people have weekly routines that falls over every 7 days. But I agree with your point that they might not be doing that something naughty in that weekly routine. It might be every couple weeks, every 3 weeks, every couple months. So I think they need to re-look at it. But I mean, I don't have their set of data in front of me, so I can't really say to that specifically. But that's my hypothesis on the matter.
Yeah. Well, if you have a cell phone,
But I've had
they have the information already. If you haven't seen the TED Talk that was presented by Malte Spitz, he asked for the information from his cell phone company, and you could actually predict where they were going to be, who they were going to be with. I encourage you to check that out. I threw it in the chat there. So.
But that's again with people with a routine. I mean, if someone's tracking me, I don't have a routine. I live in a different state every few weeks, you know. I mean, I had a case recently that actually finally came to fruition, and the person, we caught the bad guys, let's just say that. But it took a year to gather that evidence. And then they finally slipped up in conversation and gave me the piece of evidence I needed.
Is this study at the very beginning of it? It was whether or not you needed a warrant to get the GPS data. Is that still part of the fundamental part? Because if sorry, I was going to link this back to being photographed in public, and I can't remember how I was going to do that.
The law has probably been
tracking vehicles.
Different.
No, here.
This court case, and the one that established a precedent was based on 3 days. But I'm going to guess that law enforcement has certainly done it for longer periods of time, and probably, perhaps, dependent on the judge. Some judges may take a more liberal, some a more conservative interpretation of the period of time. But man, a private investigator, you're talking about a divorce, perhaps. You're not talking about breaking the law. You're talking about, the wife or husband trying to gather evidence for a divorce hearing. Maybe you're talking about someone who's faking an injury, something like that.
You don't necessarily have to have...
No, I'm involved in a case where a guy...
Go ahead.
Sorry, I was going to say, I was involved in a case where a guy, it turned out he was a con man, and he put a lot of money away from a lot of different people. Like basically, people with money who have disabilities or elderly or things like that, he was taking advantage of. It turned out to be a really big thing. So it's not always a small thing. Sometimes it's a big thing. And that's a criminal case then.
I keep forgetting what I'm going to say, damn it. Oh yeah, stingers. They don't have to track. They don't have to get like the GPS data from your cell phone or whatnot. They use what's called stingers. I believe it's called stingers. Yeah, that's fake cell towers. They put up these fake cell towers, and they track your locations with those. And there's a big movement on trying to figure out how these stingers work. And apparently the U.S. Marshals got involved, which even the judges on the cases have said is really weird, and trying to block it or whatever, because there's these NDAs with the company that makes them or whatever. But that's a big way of tracking people nowadays. So.
Along with the license plate RFID readers as well.
Yeah.
But I guess one thing that I've wanted to clarify is just from a judicial point of view, people may interpret the unreasonable word differently, because some people might think unreasonable just means that it hassles you because you have to dig out your identification from your pocket, and they may assume that unreasonable, if it takes you no time and they're just checking, then it may not be unreasonable. Whereas other people may say that any information that someone does not need to know is unreasonable. So would you be able to comment on that?
Well, me?
Yeah.
Yeah, okay.
You're the closest one to a lawyer we got here.
Okay. Sure. So the word reasonable in law means what? Hang on. What the general
Unreasonable
population.
children.
What? No, she's fine. So what the general population will consider to be reasonable. So if you took, just for an example, if you took a poll of 100 people, what would the majority of people say is reasonable? And that's why juries don't have, certifiably insane people on them. They generally don't have really well-educated people on them because they need to be getting reasonable from the average of society. And yeah, so that's what reasonable means, basically. So it's not what I think is reasonable. It's not what you think is reasonable. It's what our each individual society, our community thinks is reasonable.
Interesting.
Wow.
Another
And that's what the
aspect
idea behind juries.
of monitoring, because now corporations are increasingly monitoring their employees. Now, on the job, absolutely. If I'm at work and I'm using a computer or something, and they have every single right to monitor what I'm doing. If I'm talking to somebody on a cell phone and I'm at work, that becomes a question mark. But then some corporations have gone beyond that, and they've tracked people's comments on Twitter and Facebook, and in at least 1 or 2 cases, they've fired people for their comments that they made off the job on Twitter and Facebook.
Oh yeah, that's been going on for years.
Sure, but I think if you have where you work on Facebook, because you have your employment history on Facebook if you want to put it on there. So if I'm working, and there are companies that I have not listed on there. So if I'm working for a specific company, and anyone in the world can log in and see that I work for that company because it's listed there, and then I make derogatory statements about the industry or just anything, any stupid, then I'm representing that company at all times because I put it on my own Facebook. That's not cool. I wouldn't want people who work for me, behaving like idiots on Facebook if it's known that they work for me. So I think if they have the company listed, then yeah, you're asking for it. But if you don't have any time anywhere in the cyber world with that company, then it shouldn't matter.
There are, on the other end of this, eavesdropping company spectrum or whatever, there are companies that won't hire you if you don't have a Facebook account because they think you have something to hide.
Really?
Yeah, there are companies that will not hire you if you don't have any social network, whatever. Because they can't research you.
This
They
is
don't
why
know
I don't work
what
for
you're
people
about.
anymore.
Right? Yeah.
Oh yeah, recruiters look at your Facebook. So they,
I don't think I could work for anyone anymore.
Yeah, no, over the course of my career, I've been trying to find jobs where I have fewer and fewer interactions with people. It's hard to find.
I don't know. It obviously depends on the corporation. And I'm going to guess. Let's say you're super smart, you're the greatest salesperson in the world, and you can make this corporation bunches of money. They could care less if your tabletop dancing pictures show up, or they could care less if you say, my boss is a jerk. It comes down to, eventually, how much value you represent for the corporation. But what will happen is, if they want to get rid of people, that's when I think they'll say, okay, this is the reason why we're getting rid of you.
I agree. If in any state, say for example, you're driving your car down the road, if you just speed even 1 or 2 miles an hour, the police officer can still pull you over. But they don't really do that. A lot of laws are put into place that are questionable, so that if you are ever doing something that someone doesn't like, they can press you up against that law. That they can say you violated some law that everybody else violates, but they just want to prosecute you on it. So I don't know. Maybe you might be able to comment on that, and maybe I'm just a conspiracy theorist. But I feel like if the president wanted to throw me in jail for some reason, he could find some reason to do that, even if I've been what would be seemingly a completely, innocent citizen.
On the leniency of like speeding laws and whatnot, I know at least in Nebraska, this is like the one thing I remember from like learning how to drive, is that in the manual, driver's manual, it says that you will fail the driving test if you exceed 6 miles over the speed limit. But anything like you're trying to hit the speed limit or stay below it or whatever. But if you accidentally accelerate just a little bit over it, you can still pass as long as you don't go past like 6 miles over the speed limit.
I have another question about this. If you're I'm trying to remember what I wanted to say. Sorry, my mind's zip, it's gone. Yeah. I was thinking about. I know what it was. It was technology advancing faster than the people who make our laws are able to understand it. So that you have, in the United States, older people in Congress. They really don't understand the implications, the capabilities of technology. And in particular, when you talk about government, the government's use of technology, the government's ability to track people, perhaps use facial recognition software to track people, perhaps being able to, if you've got a camera or something in your home, they can, using the internet, track you at home. And I don't want to be too libertarian about it, but that, I think, does concern me. That's a little something. I mean, the overuse, the potential overuse of technology by government, and the inability of legislatures to really understand what we're talking about, or how that technology can actually be used.
So I used to and still kind of do feel like this problem will be solved eventually with death. Like they'll get old and die, and we'll get new people in. But the majority of the population doesn't understand the internet and technology. It's only the tech sector that does. And so...
Yeah, I think it's just the porn.
Well, even the kids, they don't understand how it works. They use it, but they don't connect the dots for like things to things. I mean, some of them do. A lot of them are very smart about it, but others not so much. So you're hoping that the people that know about it get into politics, but that might not be the case.
Right.
And so it may not be solved with death.
Mm.
Or retirement.
Well, that's my plan. I was running Dander colony before I found out that I was pregnant, so I decided to have a baby instead. But I do plan on running again in the future.
Right, yeah.
Kind of interesting, Pamela. Your daughter's name is Chelsea. By any chance, is that to honor Chelsea Manning?
Yes, absolutely.
Kind of thought.
Yeah.
Yeah.
But not the middle name because it's Elizabeth. For Chelsea Manning, it's Elizabeth, and I'm not really into Queen Elizabeth or anything like that. So my Chelsea has a different middle name.
And I'm thinking of the American response to Chelsea Manning's revelations. I strongly suspect very few Americans really understand the implications of what was revealed, if I can use that term. I can see where people outside the United States might have, because it exposed some of Americans' misdealings through our diplomatic initiatives. But I don't think many Americans, and even with Edward Snowden, okay, he's a better PR guy. He's a real slick guy.
Really? I hate listening to him talk.
But even there, I really have to wonder if even the vast majority of Americans have any clue of the implications of the kinds of revelations he's talking about, or even they're concerned about it. How much power we're giving to the government.
Yeah, but that's because, and it's not just America, most people are enslaved, and all they can worry about is the next paycheck, is their mortgage paid, is their rent paid, do they have a table, do their children have shoes? That's all they have time for. And because they're enslaved by this stupid system that's based on money that doesn't exist, because it's not based on gold anymore, it's based on the fiat banking system. It's based in debt. And they don't even realize that they're enslaved. So they don't have time to worry about it, you know?
Yeah, it's not really on most people's radar. It's all about paying rent, getting food, paying rent, getting food, going to work.
Survival.
Right.
How much of it is even on Congress's radar? I know you got some Democrats talking about it, but really, I'm not sure there's going to be that much coming out of, even what Snowden is talking about, whether there's going to be any real impact on the NSA.
With Snowden, there definitely was an impact, because there's all of these these programs that are being shut down by Congress and whatnot, and partially the president, mostly reluctantly, partially with the president. If he hadn't done that, then the PRISM program would still be at full swing, etc.
This is slightly off topic, but pretty funny. You don't see the CIA getting on Twitter yesterday?
Yeah, that's a stupid tweet.
Oh, I thought it was hilarious. I mean, it blew up Twitter. We can neither if this is our first tweet.
It's probably not their first tweet. I'm sure they have many other accounts.
Oh, God, yes.
Oh, yeah.
Yeah.
And they were only following 2 people, and one of the comments was like, I seriously doubt the CIA is only following 2 people on Twitter.
So a lot of my thought is that my libertarian leanings are partly because we have, I think that generally the politicians we have now and the people we have now are good, and that they are trying to do the best for the American people. But I feel that if we ever happen to have a war or a great recession, that someone could seize power that would be like a Hitler or a Mussolini or some dictator. And if all of these tools are in place, if Hitler had all of the power that the CIA has, that we have, then everyone would be.
He had it. It just wasn't with computers. It was with a bunch of people.
Well, yeah. I mean, he didn't have the power that we have now today to track people, to get rid of people that tweet on somewhere that they don't like him, right? And we have to, I think, look into this digital rights a lot more than we have. That it's as fundamental, like the internet anymore, for example. It's been a tool for great freedom, but I think it could be a tool for great oppression as well if we don't take action to make sure that the checks and balances are put on it that we have in the rest of the government, to make sure that no single person can control any single thing.
Like I tell most when anybody who's like, oh, government never gets anything done, it's like, well, the U.S. government was specifically designed so nothing got done.
Yeah, I always say it's a low-pass filter so that the crazy ideas don't get through, but the good ideas don't get through either. It's usually just a status quo that gets through.
Right.
And that what we want is the government to only control the things that it needs to control, so never give it any more power than what it needs. And the question is, how much power does the government need? And different people have different answers to that question. And I think generally in today's society, most people feel that they don't really care. They're trying to live paycheck to paycheck, but it's a huge deal. I think the internet is if you want to get a job, you have to look online, right? Right now, you could get away without looking on the internet. You could probably find a job, but in 20 years, you won't be able to. You will need the internet to survive in our society. So does that make it a fundamental human right? Does
You
that
might
make
be
it some?
like
Yeah.
currently like
It is according to the United Nations.
Yeah.
currently like to get a job, like a career type job, yeah, they're only hiring through like their website or whatnot. But you could probably walk into any fast food joint and say, "Hey, are you hiring?" Or like any really small business thing and ask for jobs that way.
Yeah.
But
Yeah, my concern is Homeland Security. Now, after the Twin Towers attack, people obviously were traumatized. Our government, our officials were traumatized. So we create this agency, Homeland Security, and I don't know how much oversight, if any, exists over the Homeland Security Department. I don't know what limitations they're acting under. That's my concern. Certainly Congress, from what I can see, I don't think Congress has any kind of exercising any kind of oversight over Homeland Security. I mean, they can simple things like if you're coming into the United States when you've got a computer, they can take your computer. Even an American citizen, it doesn't make any difference. They can take it and hold it for like 30 days. I don't know what restraints. I mean, our whole system of government is based on balance of power. Mm-hmm. Homeland Security works for the President of the United States. The President of the United States may be the only one who can say, okay, Homeland Security, you can't do that. I don't know if there's anyone else, not Congress, that has the ability to place constraints on Homeland Security. That's my main concern.
That I don't know, but I will say to Chris's earlier concern about like there being a big disaster or something and like a totalitarian regime getting placed in the U.S. or whatever. It's like of all the governments in the world, that would be like the U.S. would be like the hardest one to do that type of thing with. It's just too. It's just too. There's just too much to it. It's too. I don't know. Like all these totalitarian government regimes and whatnot are in really small countries. Like the U.S. is over 300 million people. Like you can't. Like you'd have to be able to control the National Guard, all of the police forces, the Army, Navy, etc., etc. And they're all independent entities.
Well, it's not an issue of stealing power. It's an issue of people giving them power because they feel that there's another greater need to combine the power. And, of course, once power is given, it is never relinquished. We still have the War Powers Act that was in the Vietnam War that was only supposed to allow the presidents to put troops somewhere for 60 days, and it was supposed to be ended after the Vietnam War, but it's still there. So my concern is that this power is it's always growing bigger. It's never growing smaller. So, someone can mean the best, but like one of the biggest examples is just say someone wants to improve efficiency of the world, right? They just want to use our resources better. So let's just say that they have the power to control every resource, and they mean the best and they're trying to do well, but there's still going to be a lot of things that happen because it's their opinion, it's their thought. You're not getting the balance of power that you need to include the rest of everyone on the planet. So yeah.
I always said you can say what you want about totalitarian regimes, but they get stuff done.
Yeah.
Has everyone here read 1984 by George Orwell?
I have. Yes. I didn't find it to be as exhilarating as everybody else seems to think it is, but.
No, it's not exhilarating, but it's just that we're living it now.
Well, we're beyond.
Maybe there's a bigger enemy out there, and they'll do whatever you say. Hit home.
We don't currently have any. Well, I can't think of anything off the top of my head, anyways, of the specific situation where he was like what is it? What's that movie? Clockwork Orange style. Is that like Orwellian? Like the situation where like they take a citizen. And, actually, I've never seen that movie. I can't say that. So, but like the whole like
What movie?
He's captive, tortured. They release him back, and he's all for the government or whatever, right? That's what happens in.
Yeah.
It's 1984.
Right.
Yeah.
Yeah, but I don't know of anyone where they actually
You're
do
thanking
that.
them for taking away all your rights. Oh.
Right.
Yeah.
where you're giving up all your rights of privacy and everything for protection? You don't know they're doing that?
No, I'm like, no, I get that. We're totally there for that, but like the actual what happens to the character, right? He's against the government, and then it turns out his closest friend or whatever was actually a government agent, and then they take him into like the back room or whatever and torture him or whatever, and then he comes out as all for the government. I don't know if anywhere where they're doing that specifically.
Yeah.
It's called the U.S. Army Indoctrination Program.
Not yet.
Boot camp is what.
There you go.
I'd rather do that.
Yeah, but what I can say is that I don't think any of this is happening yet, but we're putting in the technology can fill in those gaps so that if there ever comes a time in which someone comes into power that can do that, they will be able to. Whereas in the past, every dictator has failed. Like, you know, they couldn't kill everyone because they didn't have an exhaustive list of everyone in their towns and where everyone was hiding, and RFID tags and video cameras. But in today's society, we do. And I think we have to reevaluate our fundamental rights in this new digital age. And even if not for privacy and security, there's other things like the ability to live forever, the ability to live on other planets that fundamentally change humans from where we once were in the Stone Age to now, where we're almost evolving past what we were a long time ago. So bringing up these questions is important, and you know, I don't have the solutions. I just have the questions.
Okay, so here's my.
No, that's halfway there. That's a good start.
So launching off of that, going like space exploring and whatnot, and it's done mostly right now by government organizations, specifically like the U.S. and Russia and China have astronauts, or well, that's not true. So
Space
like,
program.
yeah, there's the ESU and all that whatnot. Spacefaring nations. Let's go with that. Okay, so they're doing all this exploring. If they establish research outposts on other planets or moons or what have you, or just like orbiting colonies, will the colonies? Are the colonies going to obey those governments, or is it going to turn into like a Gundam thing here, where they're all rebelling and there's like there's the Zion forces and the Federation and et cetera, et cetera?
It just all depends on what happens in the future and how, you know, loyal those people are and how dependent they are. Because imagine maybe if you cut off their resources, they might die.
So just look at the American Revolution. The colonies were all fine, working for the Queen, until effectively taxes started to get a little bit too high, and then the government in England said, well, okay, you're Americans, you should pay for all the troops and things we have, and you know, you're part of the colonies. You're part of
The British Empire.
the British Empire. And the Americans reached the point where they said, you know what? We don't want to be part of this empire anymore. We're better off if we're independent. Not as simplistic as that, but basically that's what it was. So if we have a colony on Mars, as long as you've got people on Mars say, you know, the Earth, they're helping us out. We need the Earth. They're giving us stuff we need. But at some point, if the people on Mars say, you know what, why should we cooperate? Why should we accept controls from the people on Earth, let's just be independent. And unless you've got a Death Star, you know, in the offering, there's not a heck of a lot you can do. To defeat a colony that's that far apart, I don't know.
Actually, no. For a small colony, there's a lot you can do to impress them. You could. I mean, we're really good with sending probes to fairly specific points on Mars right now. We could send a nuclear missile and just obliterate the colony quite easily.
Why would we want to?
I don't know why we'd want to, but if you're trying to put down a rebellion, I mean, they're on another planet, so you really shouldn't care.
It doesn't sound like.
But if it's a totalitarian regime, right? They don't want any whatever, right? So
unfortunately, our weapons outpace our defenses.
Right. Yeah. Right. It's like you could even just do it with a kinetic impact. You could just send a big chunk of steel and have it strike the camp, and it would be a big enough explosion that it would wipe them out. It wouldn't have to be a nuclear bomb.
Well, you could also bury yourselves underground. So you know, it's usually your attacks outweigh your defenses, but you know, we have bombs, we have bigger bombs, we have even bigger bombs, but
depleted uranium bunker busters.
People who want to survive, that's a pretty strong defense. If you just have the will to survive and the will to resist, you know, all throughout history, that's come in handy. And it would the distance helps. And you know what? Every war, you know, a lot of ways it's also a public relations thing, because if it's not very popular to bomb Mars, then the politicians aren't going to do it. So
I'm still a strong opponent whatever. I'm still a strong believer that we should deorbit Phobos and Deimos. Not that we really know how to do it, but I think we should do that first before we colonize it. Warm it up a little bit.
I'm curious to know how exactly, you know, there's that movie with Arnold Schwarzenegger, how exactly to create an atmosphere on Mars. How would it be done?
This is my idea. You crash Phobos and Deimos into the poles, and that creates a cascade of like the CO2 gasifying or whatever, right? And then that fills it up for a while. I mean, eventually the gravity and the lack of a magnetosphere will erode the atmosphere again, but it might be good for a few tens of thousands of years.
Yeah.
At which point we might be able to create a dome around the planet, or artificially increase its gravity.
We know that it had an atmosphere and liquid water for the first, was it a couple billion, or for a long time before it was there.
So if we can give it an atmosphere,
mm-hmm.
I mean, there's, I don't know the mass of the caps or whatever. I'm sure there's data on that someplace as to like how much you could really fill up the atmosphere by doing that. But I mean, if you can warm up the planet enough that the water melts from the surface, because there's what, a liter of water in like a cubic meter of regolith or something like this?
It's something like 2% of the mass of the soil on Mars is actually water.
Right. So if you can liquefy that, like probably right now it's ice, because the surface of Mars doesn't really get above 20 degrees Fahrenheit or something like this. So, but if you can warm it up, then you could start the atmosphere going. You could start a what would it be, like a convection system or whatever, or you know, like the whole cycle of the jet stream and ocean currents and all this, how they're all kind of connected together and they form our somewhat balanced biosphere or whatever. You get something like that going, I think you're good to go for living outside of a spacesuit, perhaps.
Let me interrupt you guys for a second, because I have to go and Pamela has to go. I'll leave the Hangout open, stopping the